I think we're live. All right, welcome to Data Science Club Notebook of the Week number 8. This week we're going to go through recommender systems part 2, building a recommender system in Pandas. So last week we went through the first half of this particular notebook. It really goes into depth in data cleaning and data prep for this particular problem, and so we're just going to continue in there and build the actual recommendation system at this point. If you remember from last time, the whole point of this is to build a recommender system. We're using movie information. This is probably one of the places where we all interact with recommender systems a lot. If you use Netflix or Amazon Prime Video or anything like that, you'll get recommendations of what you might like to watch based on what you have previously watched. And so this code is kind of walking us through how you would build that system. And again, as of last week, we went through all this stuff of cleaning the data, shrinking the data type size, so in case we had really large databases, that we wouldn't use up a lot of space for things we didn't need to use up space for. And now we're getting into the guts of how to actually build a content-based recommender system. All right. We can look at this here. It looks like in this one, we're building a content-based or item-to-item recommendation system. And so what we're trying to do here is to find what the user likes about the movies that they're watching and then recommend other movies based on those features. And I think given the features that we have previously, I think we're just going to be looking at genre primarily in this, because I think that's really all the information we have.
Yeah. And in this example that we are creating a profile for pseudo user called Lawrence, and we are predicting we are making a profile based on the ratings that he or she has provided for the different movies that they have watched. And all these movies like Predator and Final Destination had a genre associated with them, and those genres would have got those ratings for that particular user. So
so let's see. So if we look at Lawrence's profile here, we can see, like Ravi said, what the rating is that they gave. Now, I don't know what rating system they're using, but it's got a lot more gradation than Netflix, because I think Netflix just lets you do
4 stars or 5 stars.
Integer recommendations between 1 and 5, not 4.9. But apparently they really like horror films, and isn't Waiting to Exhale a romantic comedy or something like that? But apparently Beverly Hills Cop they rated really lowly, which I don't understand, but that's okay. All right, so they don't like old Eddie Murphy movies. So if we run that cell, then we'll see what that looks like as a data frame. Again, all the same information that was up here above. So now that we have that complete, what we need to do is merge this with information from the larger movie data frame so that we can correlate the two, or create some correspondence between Lawrence's ratings and ratings of other movies in general, and the genres. That's right. So this first one says, okay, so create a new column here called Lawrence Movie ID that is going to be created by returning the movie ID if, this is actually making a whole new data frame, right?
Yeah.
Yeah, okay, so this isn't just a column, this is a whole data frame that is a subset of the movies data frame where the movies in this Lawrence movie ID are the ones that Lawrence had in his movie ratings data frame.
Yeah, so it's basically going into that big movies underscore DF data frame that we had, and if it can find that title that is there in Lawrence movies inside that big data frame, then it returns the corresponding genres or movie IDs for that.
Yeah. So now if we take that data frame and we merge it with Lawrence's movie ratings, then that's what we get below here, is this data frame. So here we've got the movie ID, the title, and you see here, up in Lawrence's movie ratings, all we had previously was just rating and title. Now we have rating, title, and then we've also added, because of this merge, we've added these extra columns we didn't have before, which is movie ID, genres, and year. All right. So apparently in this recommender system, we're not going to use genre or year. So we're going to drop those just to make our data frame a little bit more lightweight. Oh, I don't think I actually ran this previous cell. There we go. There we go. All right, so now we're going to learn Lawrence's profile. So we're going to convert Lawrence's movie ID data frame into one that includes the one hot encoded genre, so that we can match that with other things later.
Yeah, and if people remember it from our last session, one hot encoding is basically giving a 1 rating to one of the genres that are included for that movie, and 0 if it is not a part of that movie.
Yeah.
So for instance, the first one, Waiting to Excel, has comedy, drama, and romance. So for adventure you give 0 rating, animation you give 0 rating, but for comedy you give 1, and romance again 1, and
assuming we have a drama column somewhere, probably in this ...
Yeah.
That would also have a 1. And so again, you see this is 9 rows. So this is exactly this Lawrence's profile movie ratings data frame, except here, instead of his ratings, we have the movies that he rated with the genres associated with them. And so now we're coming here, and let's see, it's saying we don't need the genre table, we just need, what do we need? All right, so what's left here?
So that just
Oh, okay, so this is just dropping the movie ID, title, genre, and year columns from this data frame. So it's the same number of rows as in Lawrence's ratings up here, but it's just the one hot encoded genres. Okay. And so now we're gonna weight each movie and each rating by the genres and the movie rating. Okay, so we got to make sure that we can do a matrix multiply, because we're going to be multiplying the genres by the movie ratings, and then we're going to add them together. And that is all done by the dot product of the transpose of the movie ratings. And so that will, oh, what did I miss? Matrices are not aligned. All right. Looks like we gotta do a little debugging here. All right. Lawrence's movie ratings dot rating. Oh.
There's no.
Yeah, there we go. All right. There we go. And then this one. There we go. Now it works. That's why you don't skip cells. All right, so now that we've done that matrix multiply, you can see that now we've got Lawrence's profile where his ratings for particular movies added weight to given genres, and that's what we see here. So like we talked about earlier from the short list, is it looked like he really had a penchant for thriller and horror movies and wasn't as interested in comedies or romance, and
A decent rating for action as well.
yeah, decent rating for action, and surprisingly a drama fan. So now we're going to come down, and now we're going to start using this to recommend movies to Lawrence. So we're going to come here and movies with genres. Okay. And now we're just going to look at the header of the movies with genres data frame. Okay. And again, we're going to remove the columns that aren't used for prediction. And so that's just the one hot encoded genres. And then now we're going to make a recommendations table data frame where all we have to do is multiply the genres by the weights for those genres and then take the average for a given movie. I think that's what's going on here. Okay. So now this recommendation table data frame has embedded in it the ratings for each movie
based on Lawrence's profile that we have.
Yeah, based on the profile that we have. So the higher number that we have here, the more likely it is that Lawrence is going to want to watch that movie. So out of the first 5, well, Waiting to Exhale is one that he had already rated, and the first 5 in here are all kids movies and adventure, so he didn't rate those very highly. So let's go and look at.
Yeah, just to keep in mind for the users, we are only seeing the first 5 rows of this data frame, but it is because we have been using dot head function.
Yeah.
But the actual data frame is way bigger in size. It's whatever was the number of rows that we had for that movies DF data frame.
Yep. So now if we sort by what movies were rated the highest and then on down, we get this here. And so now we have these movie IDs and we have the top 20 recommendations for Lawrence. And so now we need to go through these and add the movie names back so that we could actually display those to the user. And so we're going to do that. So here we're making a copy. This deep copy actually makes a secondary copy of the data frame. I found in playing around with this that there are some instances, if you just say movies underscore data frame equals copy, then copy has a pointer to the movie's data frame. It doesn't actually have a copy of it. So if you drop a column from copy and you just did copy equals movies data frame, then you lose that column in your movie's data frame. So that's why I figured out that that's why you do this deep copy, is so that you actually have two separate copies so that you can do
changes on one and not affect the other one.
Yeah. All right. So then we set the index to movie ID, and that will make it easier for us to copy the top 20 and copy that location and add the movie titles to it. And so so when we run that now, we've got movie titles. And certainly at first glance, this looks a lot more like movies that this particular user would enjoy. Certainly more than Toy Story, given the things they've already added. All right, and then this last cell is just to kill the notebook. You don't have to do that one unless you're done looking at it. The user that created this notebook also allows it to be hosted on Colab, which I think is a Google Jupyter Notebook hosting thing. But because we've done this on Research Computing's on-demand system, there's no reason to kill this super fast. You take your time. So I think this is a fairly naive recommender system. It doesn't seem to take into account what movies other people liked that had similar profiles. And the other thing is, if you've never watched a movie in a particular genre, then it has no way of recommending you a movie that's in a genre you haven't seen before. So like earlier today you were saying that the Avatar: The Last Airbender was a good anime series. If I've never watched anime before, but I might like that, there's no way for this to recommend me that series.
Yeah, and plus, while creating this Lawrence profile, we didn't check, or we didn't have that data where when at what time did they give a movie that particular rating. So if they gave some thriller movies those ratings 10 years back, and all the comedy or Toy Story good ratings now, that means that now they might be more into those kind of movies, Toy Stories. And so we are missing a lot of data.
There's no time component there. And we really did have, if we go back up to the data cleaning, we actually had a ratings data frame that included the user ID as well as the movie ID. So it would be possible to extend even just this example with including the average user rating or some kind of distance metric, like a k-means clustering or something like that, and then say, okay, if you're in this pool, then you have your weight and your cluster's weight as well.
For people watching this video, one good exercise is create your own profile based on this. Just give some movies, ratings to some movies, and try to run through this notebook again with that profile and see what are the recommendations that you get.
Yeah, we could even copy one of these real quick and just go up here and edit the profile a little bit.
So one aspect of this notebook is that it's a content recommender system, right?
Yeah.
It's not a collaborative filtering recommender system, and
Okay.
so it is focused on attributes of the content. That is ratings of the movie. In this case, it's the genre. It's a
Yeah.
feature of the content. Whereas a collaborative filtering recommender system is the one that you were referring to, which is what are other users thinking.
Yeah.
And so those recommender systems will essentially ignore, in the purest form, ignore the content that is part of this environment, and instead just look at the behavior of other users and use that behavioral information to say, if you were rating things in this way, regardless of what the content of that thing is, we'll just see that you're a neighbor or nearby a similar user as this other user. And so it kind of allows for a qualitative look at data. You're basically saying some intelligent agent, i.e. a human, looked at this data and put these ratings out there for this data. No idea what that data is or what the content is about, but if we compare users' rating across this data set, then we can see which users align in their feelings toward that content.
Yeah.
Whereas in this kind of case, you really don't care what other users were doing. You just really care what content is shared with items that that user, in a particular user, has already inspected.
Yeah.
So.
Yeah.
That's a good point.
That makes sense.
And in that way, I don't know if having the time frame of when they made the rating, would that make any impact on that?
Potentially. I mean, those are all things that you can put into further exploration and then seeing whether you can predict accurately. With leave in out type. Test and training and test data sets and stuff like that. You can start to see how much impact and influence does the release date of the movie or the rating of the user impact the accuracy of your prediction. So those are just, it just becomes data science at that point, right? How much data can I throw in here to not overfit and to provide a good model for what's happening?
Yeah. No, I mean that's really interesting, and it's funny when I tried to change the profile and then started going through. There's actually 2 instances of the omen in the database, and so it crashes out the code here because it's having a hard time matching up the movie IDs at that point. So we'd have to do a little bit of debugging there.
People can just take a cursory glance at the movies that are available in that data frame and just add some random movies or the movies that you like, give them more ratings and try to create a profile.
Yeah. Yep. All right. Well, that's it for this week. If you guys are enjoying these videos, like and subscribe to make sure that you get them every week. Feel free to come to our office hours during the week, or leave a comment to let us know, what your questions are or what kind of things you might like to see. And yeah, until next week, we will talk to you guys later.